see my board here, but I do have stuff written on it. But my lesson today is over Pythagorean triples. It would be an 8th grade geometry lesson. So, first to start, we're going to review Pythagorean theorem. And we know that, because we've gone over it in class, we know that that is
a squared plus b squared equals c squared.
Exactly. Now, the question is, though, what type of triangles can we use that on? We can only use that on right triangles, correct? Okay. My question is, in case you didn't know, Corey's over here. Wave. There's Corey. He's hiding. Okay, my next question is, so we have our triangle down here. What side, where are all these labeled? Tell me where C is first.
The long side.
The long side. So there's our C. Now then, we have an A and a B. Does it matter which one is A and B? Nope. Okay, because our A and our B are interchangeable legs because we have a right triangle. So I'll label this one as A and this leg is B. So there's our Pythagorean theorem. Now, okay, the history behind this and how we can find, we're doing Pythagorean triples. That's what we're doing. That would be, a Pythagorean triple are three numbers that will satisfy this formula of Pythagoras, but they have to be whole numbers, they have to be integers. So you can't have root 12, not root 12, but root 10 as your C. You have to have counting numbers for A, B, and C. So, to do this, Pythagoras has a whole bunch of them. They came up with a whole list of them that goes on and on and on. You can keep finding them forever and ever. But Pythagoras wanted an easy way to come up with these perfect triples, these Pythagorean triples. So he came up with some really cool formulas that are in the History of Math textbook, but take a little bit of extra work. So Plato then took those and worked on them a little bit, and he simplified them down even further. But they could even be simplified even further. And so that's when Euclid came in, and in his Elements book, came up with this. And he has, so for our A leg, that would be 2 equals n. And then for our B leg, it's n squared minus n squared. And then for our C leg, it's n squared plus n squared, where n has to be greater than n. And so that was Euclid. And the n and the n, so the n number is just a value that we came up with. And our n is going, for simplicity's sake, we're going to go one less. So in class today, I'm going to show you a couple examples, and we're going to go through them together. And then you'll break into smaller groups, and you will finish the rest of this chart. And so we're going to, as a class, we're going to find 30 different Pythagorean triples, and we're going to come together, and we're going to fill all of our charts out, and that'll be the class today. So, we'll start off with our n, that will be 2. So looking at our A leg, we're going to find our A leg first. So if our n is 2, that means our n has to be less than 2, and it has to be an integer. And it can't be 0, you can't have 0 length. So our n is 2, that would make our n 1. Good. So looking at our formula, 2 times 2 times 1, what would that equal? 4. So if you'll fill that into your chart, you know our A leg is 4. So now we're looking at our B leg, which is n squared minus n squared. So what would that look like? 4 minus 1, which is
3.
Good job. It is 3. And now for our C leg, we have m squared plus n squared.
Which would be 4 plus 1.
4 plus 1, and that would be 5, correct? So that would be our first Pythagorean triple. That is the one that most people think of when we think of Pythagorean triples. So if we put that into our Pythagorean theorem, this would be 4 squared plus 3 squared equals 5 squared, which would then be 16 plus 9 equals 25, which that's true. So, it's a Pythagorean triple. Okay, so let's move on to m equals 3. So for simplicity's sake, let's make our n 2. So we're just subtracting 1 from n to get that n. So that means for our a leg would be 2 times 3 times 2, correct? Which would be 12. And now then, our b leg is m squared minus n squared. I should have come up with different letters instead of m and n. They sound too similar. So, that would be
9 minus 4, which is 5.
which is 5. And our c leg would be
9 plus 4.
9 plus 4, 13. And you all can go back through and check to make sure that that fits the Pythagorean theorem, which it will. So now we go to n equals 4, and that means our n is 3, which makes our a leg 24.
2 times 4.
And now our b leg is m squared minus n squared.
Should be 16 minus 9.
Would be
7.
7. And then for our final c leg,
16 plus 9, and that's
25. And again, you can go through and check to make sure that that fits the Pythagorean theorem. So now what we're going to do, we're going to break up into groups of 3. Each group will have 3 more triples to do, and then we'll come back together as a class and we'll fill out our chart, and that'll be it for the day. So, time to break into groups. Thanks, Corey. And I'll show you my board. Oh, it's backward. You can't even read it. Okay, never mind. Bye.